You see the limitation of the source follower output stage because of the distortion at the end, right? Then naturally, some of you may think, well, the reason that I cannot go down is because I have NMOS on the top. What if I have PMOS at the bottom? Then maybe I cannot go up. Then what if I have both, right? So this one, you can spend time to think about how you can come up with these circuits, but it is just given to you here, that how people use it, and then let's analyze to make sure that this works. This is V in. And let's look at this carefully. What is the transistor on top? NMOS, very good. So where is the source? Where is the drain? If it is NMOS. Drain should be at top, right? Higher potential. So this is a source follower, right? Like a source follower. How about the bottom is a PMOS? The top is what? Source. The bottom is drain. So it is an inverter. It is not. An inverter is what? Inverter is this. You have the PMOS on top. PMOS on top. And NMOS at the bottom, right? So it's completely different. Okay, so both of them are in the source follower configuration, right? So that's why, again, why we need to understand where is the source and drain. This is very important, right?
So
this is not an inverter. This is called a push-pull stage. Later you will see that you try to push the current to the low, and then the PMOS is going to pull the current from the low. Here you already see that it pushed the current to the low. But here this is just it's just a constant current. It's pull the current, but not due to your input, right? So the idea naturally is that I want to have a NMOS here, a PMOS here, to push the current to the low and pull the current from the low to form a push-pull stage, which is very common in the power amplification, right? So I will just tell you that, right? And you can try to check yourself. We will check, but try to think about how they come up with this. When V in is larger than VTH of N, when V in is larger than the VTH of N, okay? Then you will find that V out equals to V in minus VTH of N. That is exactly the function. This is V out of a source follower, right? V out equals to V in minus the VTH of N. Then you may say, how about the PMOS? And I claim that at this stage, PMOS is off. So if you have the inputs larger than the threshold voltage of N, the solution is that PMOS is off and you only have the NMOS working, which means that the circuit becomes something like this. Because the PMOS is off, I can ignore it. You only have this circuit. And you're pushing the currents to the transistor. Is that okay? Now, of course, you can check, right? To check this, we definitely can check to make sure this is the case. Because what is VSG of PMOS in this case? The S is the output, right? Which is V in minus VTH. Maybe let me do it in a few steps. It is V out. Maybe you tell me, right? What is the VSG of PMOS? Huh? V out minus V in. Yeah, because VSG is Vs minus Vg. Correct? And then V out, very good. V out equal to V in minus VTHN, right? So this is equals to negative VTHN. Which is negative, right? So, did I say? Yeah, so your source is at a lower potential than the gate in PMOS. Then it means that it is off, right? If you go back to those equations, right? Because this is smaller than the 0, right? So it is off. Right? I don't want to check the equations. So this is one scenario. Okay, then I keep lowering my V in until I reach VTHN. Then something happened. I don't want to talk about that. Then think about from the very negative. If V in is less than VTHP, right? Remember, VTHP is negative. It's negative 0.4 volt, right? So I come from the negative 5, negative 4, negative 3, negative 1, negative 0.5, negative 0.4. All these are less than negative 0.4, right? What happened? I claim that V out is still equals to V in minus VTHP. Now, but because VTHP is negative, so basically V out is higher than the V in. Okay, and at this stage, the NMOS is off. Right? I can check again. I do the same thing. I try to check. What is VGSN on this figure? What is VGSN? VG is V in, VS is V out, right? And then again, I claim that V out equals to V in minus VTHP. So this is equal to negative positive VTHP. Right, but remember VTHP is negative. This is smaller than 0, right? So again, if my input is less than the threshold voltage of PMOS, NMOS is off. So again, I can write this. I can draw the circuit as something like this. Looks very weird, but it is correct. Difficult to draw. And what I want to say is that now the current is going from here to here. That's why you pull the current. In this case, current is going from here to here. You push the current. That's why it's called push-pull. Okay? So we have this one. Is that okay? Any questions? Now, but how about the region between VTHN and VTHP? Both of them are going to be off. You can check that, right? So maybe I finally, just to show you what it is. So when VTHP smaller than V in, smaller than VTHN, then both off. So basically, it's not connected to the output. So the output will be 0 because when you're sweeping, eventually bring it to 0, right? So because of this, if you look at the V in versus V out graph, again it's shifted. Shifted by how much? Shifted by VTHN, right? Because again, they will shift downward. Okay. And then from another side, you also have this curve. It's shifted by VTHP, which is negative. And this is your final curve. Okay, so you don't have limits anymore. However, at the middle, you have distortion. If you try to draw the relationship between the time and the signal, this is the voltage, right? So this is your input, for example. This is your input. And what will you get? You will get this. Everything will shift down by VTHN. Here, everything shift up by VTHP, VTHN. And then you have distortion in this region. This is V out. Okay. My drawing is ugly. I copy from the book some of the drawing. You can take a look, right? So on the top here is the source follower, right? It tells you that you have the loading and how it pull the current and push the current. On the right, this is push-pull, right? And it tells you that when you have high voltage, the PMOS is off. Low voltage, the NMOS is off. And you have this distortion. So actually, yeah. Okay, I give you this back to you. Any questions? If no, we can stop here. But in another one, if you have this swing, most of them are flat out, right? So the distortion will be more than this.
There's less distortion overall, but this would generate more.
I don't know.